Today's lesson is about power and energy. Our learning objectives are to explain what the power rating of an appliance shows, to explain how we can reduce electricity bills, and to explain how this helps the environment. At home, our electricity comes from the main supply. That's the hole in the wall. Electricity is delivered at 230 volts. This high voltage means that the electricity can transfer lots and lots of energy. The energy we use has to be paid for. The more energy we use, the higher the electricity bill. We can save money on electricity bills by switching things off when we do not need them, and by using more efficient appliances. Also, if we reduce the amount of electricity we use, we also reduce the amount of carbon dioxide we put into the air by the power stations. Next, we're going to talk about energy. Some appliances transfer more energy than others. An electric oven, for example, can transfer 5,000 joules of energy every second, whereas electric fires, hairdryers, and kettles transfer between 1,000 to 2,000 joules of electrical energy every second. Televisions and computers in your home can transfer up to about 400 joules of energy every second, whereas light bulbs and radios transfer less than 100 joules every second. Energy is measured in joules, and the actual energy per second we call power. When we're talking about electrical appliances, we talk about their power, but we don't express the units in the number of joules per second. In electrical items, we talk about power in the units of watts. So power is watts. So 1 watt is the equivalent of 1 joule transferred every second. So now we're going to talk about power ratings. Power ratings are usually found near the plug sockets or on stickers that are on our electrical appliances at home. Sometimes we call the power rating the wattage. You can see here that there are 3 different power ratings for efficiency. An appliance is said to be efficient if it transfers more useful energy than wasted energy. Wasted energy is often in the form of heat and sound. Now let's think of a light bulb. In a light bulb, electrical energy is being transferred into light and heat. Light is what we want, but the heat is wasted energy. It's something that we don't want. We call the thing that we want useful energy, and the thing that we don't want wasted energy. Now think of an energy efficient light bulb. This is doing the same transformation. Electrical energy is still turning into light energy and heat energy, but the difference is light energy is more and wasted heat energy is less. This makes it more efficient. Often, new electrical appliances will have a power efficiency rating on the front of them, for example on a fridge or on a cooker or even on a microwave. You may have seen some of these around your house. The green A is more efficient than the red part, which is G. So an appliance which has a rating of A is a more efficient appliance. This is good as a guide, but don't forget that not all appliances are left on for the entire day. So sometimes it's okay to have a less efficient appliance as long as you don't use it for a long period of time. So how do we know how efficient an appliance is? We show this using a Sankey diagram. A Sankey diagram is a type of flow diagram that allows you to see how much energy is useful and how much energy is wasted. The size of the arrow is the amount of energy, and the total size of the arrow together adds up to the total amount of energy that was put in. We can see on the first diagram that 100 joules of electrical energy has been put in, and out of that 10 joules of energy was useful energy in the form of light, and then 90 joules of energy was actually wasted as heat. To work out the efficiency, what we do is we take the useful energy and divide it by the total amount of energy put in and work that out as a percentage. Let me show you. So that's useful energy divided by the total input energy, so that's the total amount put in, and then times by 100 to work out your percentage efficiency. So that's 10 joules of light energy divided by the 100 joules of electrical energy and then multiplied by 100 to work out your percentage. What would be the efficiency of the second Sankey diagram, the second light bulb? You could pause the video to work it out and then check with your partner next to you.